Finding intercepts and quadratic functions, so these parabolas. So the first thing we are going to find are x and y intercepts. So I think we actually did this last chapter, but we're going to recap and do it again. So it says to find the x-intercept, we plug in 0 for y, because an x-intercept is a point that, you know, like 9, 0, right? We have a y value equal to 0. Okay, grab one. And then the x-intercept, x-intercept I plug in 0 for y, y-intercept I plug in 0 for x. Because a point like this would be like 0, 5, right? So it has an x value of 0. So it says find the x and y-intercepts for the following equations. So if I want to find an x-intercept, I plug in 0 for y. So I get 0 equals 4x minus 6, and I can solve that out. So I add the 6 over, and I divide by 4. So I get 6 over 4, which is the same as 3 over 2. Okay, that's a point. It's 3 over 2, 0, because we plugged in 0 for the y value. So same thing for y-intercept, we plug in 0 for x. Okay, so when we plug in 0 for x, we get y equals -6. So that's a point as well. It's 0 for x, -6 for y. Okay. So a lot of times I don't write all of this information down each time. I just I cover up the thing with my finger. Do you guys remember me doing that last year? So if I'm plugging in 0 for y, I would take my finger and I'd cover up the y squared. And I'd think, okay, 0 is equal to 16 minus x. So what is x equal to? 16, right? So if I have 0 equals 16 minus x, I get x equals 16. And then the same thing for the next one. So if I take my finger and I cover up the x part, I have y squared equals 16. Well, what if we get y squared equals 16? Plus or minus, right? So we get y equals plus or minus 4. So we should have 16, 0, and we should have 0, 4, but also 0, -4 for our intercepts. Does this make sense? Do you guys remember this? So the next one, if I plug in 0 for y, I get 2x cubed minus 4x squared. This is a GCF problem. It's something where I can pull the GCF to the front. So I'd have a 2x squared, and I'd have x minus 2 left. So I would get x equals 0, and I'd get x equals 2. So those are the points 0, 0, and 2, 0. So what about the y-intercept? It's 0, 0. We just found it, right? So it's the same thing. We plug in 0 for x. We get y equals 0. All right, do you guys remember, eventually we're going to talk about this later in the chapter, when we have a 2x squared, so x squared on the outside, so an x squared, the 0 is an answer not once, but twice. What's the word for that? It starts with an M. It was a very cheesy movie in the early 90s. You just missed out on this. It's called Multiplicity. Have you guys heard that? Yeah, so if I have an x squared, and I have x squared equal to 0, 0 is not only an answer once, but it's an answer twice. So basically on that graph, it would do like a little bounce. So an x cubed would look like this. It's going to bounce on the x equals 0 and then go straight through on the 2. Do you guys remember that? We'll be talking about that later this chapter too. All right, so the next one. So if I plug in 0 for the y, I get 0 equals x squared plus 4. If we subtract the 4 over, we get -4 equals x squared. These would be I answers, right? It'd be plus or minus 2i. So this is no real solution. In other words, no x-intercept, right? If I'm not getting a real number, there's no way for me to plot that point. Unless we have the complex plane, which we'll talk about later in semester 2. All right, so what about our y-intercept though? Do we have a y-intercept? So I plug in 0, so I have 0 squared plus 4. So I get the square root of 4, which is actually just 2. So some of you guys are probably writing plus or minus right now. I see lots of erasers. Right, the square root was already in the problem, so there was already an invisible plus in front of it. We didn't take the square root, like we weren't solving an equation where we took the square root. So this is going to be 0, 2 is our only y-intercept. All right, so number 5, we would then factor. So we'd factor each thing, so we have 2x and x. We need our signs both to be negative in order to multiply to be +3 and have our outer and inner combined to be a negative. So do you guys see where our 3 and 1 have to go? So the 3 is with the 2 and the 1 is on the outside. Does that make sense? So when we combine that and we do our outer and enter, we have negative 3x and negative 2x, which works to make negative 5x. So when we set each of those pieces equal to 0, we get 2x minus 3 equals 0, x minus 1 equals 0. We get x equals 3 over 2, and x equals 1. So we have 3 over 2 comma 0, and 1 comma 0. All right, and then number 6, what do we do on something like this, Greta?
Oh, well, I just have a question about number 5, because
yeah.
I did 2x plus 1 and x minus 3, and not...
This is one of my favorite ones to factor. Like, I like to just put these on you'll see me do this all the time in the notes, because I'm too lazy to, like, really think of something that factors well. And so I love having 2x squared, 5x, and 3, and it doesn't matter what signs I use, because every single time it will factor. But the issue with Greta's, though, is she said, oh, it makes negative 5, but you would have to do a negative and a plus. So what does that mess up, though? It messes up the plus 3. Does that make sense? So be careful with those, because it does still combine to be negative 5, right? 1x and negative 6x. But we would have positive 1 times negative 3 equaling a positive 3. That doesn't work then. All right, so the next one is a GCF one. So when I plug in 0 for y, I pull out a 10x. I'm left with 1 minus 2x. Don't forget your 1. Everybody always forgets that placeholder. Think about distributing back in. Wouldn't we need that 1 there when we distribute it back in? Yeah, if it wasn't there, we just have negative 20x squared. That doesn't make sense, right? So we need the 1 there. Set each one equal to 0, and we get 0. And what, 1/2? Yeah, 1/2. So our answers are 0, 0, which is the y-intercept as well, and 1/2 comma 0. So if I plugged in 0 for y, I'd still get that 0, 0. Okay, feel good with x-intercepts, y-intercepts? Perfect. All right, now they might have denominators. What if I had like x minus 2 over 3x squared minus 1 equals 0? So if I was trying to find the y-intercept, I'd set my y equal to 0, and I had something like that, x minus 2 over 3x squared minus 1 equals 0. What's the only x-intercept in that case? 2. Yeah, so we don't worry about the denominator at all, just the top. Because the only way to get 0 for a fraction is to have like 0 over 7 equals 0, 0 over negative 5 equals 0, right? Does that make sense? So the numerator is really all that matters in something like that. I should have put one of those in there as well. All right. So definition of a quadratic function. So when you see something that says like y equals a number, x squared, plus a number times x plus a number, right? That's a quadratic equation. It's a parabola. I think you guys all know what that is. And parabolas are symmetric with respect to a line, a fold line that we call the axis of symmetry. This is all ringing bells. You remember talking about this in Algebra 1 and Algebra 2? Yeah. The point where the axis intersects the parabola is called the vertex. So it's like the bottom or the top of the parabola. And it opens upwards if A is positive, and downwards if A is negative. So who can remember how to find the axis of symmetry? There's an equation, x equals, nothing, crickets, negative b over 2a. Oh, yes, you got it. I was really hoping you guys remember that. All right, so that's to find the axis of symmetry. So that will find the point that's directly like in the middle for you. It will find its x value, and then you just plug into the equation to find that vertex, right? So that's what we're doing. So on the first one, first of all, does it open upwards or downwards? It opens downwards. So we're going to have our vertex at the top of the parabola. So if I do x equals negative b over 2a, I get negative 6 divided by 2 times negative 1, so I get x equals 3. So that's like the dotted line that we're going to fold our parabola over on. And we know it goes downwards, but we don't know like where it's located on that line. Like, is it right here? Is it here? Is it on the axis? I don't know. So that's when we have to find the actual vertex, right? So we need to find the y value that goes with it, because this is part of the point. So it's like 3 comma what? We don't know. So we go back to our function and we plug in 3 into the function. So we get negative, and be careful, the x is 3 and the x value is being squared. So if you want to put a parenthesis there, that helps, like 3 is being squared, and then we do the negative. So plus 6 times 3 minus 8. So we get negative 9 plus 18 minus 8, so we get 1. So that means my vertex is at 3 comma 1. Would we call that a maximum or a minimum? It's a maximum because it was a downwards parabola, right? So we're going to say a max of, what's the highest y value? 1 at x equals 3. That's how we write it. Max of 1 at x equals 3. So like if you go into AP Calc, they'll always say, find the absolute maximum value. Well, if I'm finding a maximum value, I'm finding the y value. Okay, so a maximum is a y value. All right, so same thing for this. So we do x equals negative b over 2a. So we get negative 8 over 2 times 2. So negative 8 over 4 is negative 2. We plug in the negative 2. We do a lot of magic. And we get what? So let's see. So we got 4 times 2, so 8 minus 16 plus 7. Negative 1. Okay, is that a max or a min? This one's an upward, so there's a minimum. So we're going to say a minimum of negative 1 at x equals negative 2. So this has nothing to do with it being a positive or a negative number. Sometimes people are like, oh, I got a negative, it has to be a minimum then. Well, maybe you have something that's over here, right? But it's still a maximum. That could happen. So don't assume just because it's positive or negative that it's a maximum or a minimum. All right, so we'll stop there for today. Talking about parabolas. And we were talking about when things were in the form y equals ax squared plus bx plus c. So typically books will call that standard or general form. But for some reason your textbook calls vertex form standard form. So if you see problems that ask you to write it in standard form, just know that they're talking about vertex form. So we'll talk about that today. So it says sometimes you will be asked to write a quadratic function in vertex form. This means that you need to write the function so you can easily see what kinds of shifts have happened. Has it gone to the right 2, up 5, what has happened? Okay, and a lot of times in order to do this we use completing the square. Do you guys remember completing the square? All of you just got this look of panic. All right, it's not very fun to complete the square, right? So there's probably an easier way. I'm going to teach you both ways, okay? So it says if you don't like this method, you can also quickly find the axis of symmetry and then the vertex, right? So you can find the vertex, how much it's moved over and up with using x equals negative b over 2a. So we did that yesterday. Okay, so the vertex form of a quadratic function. So this is what I was saying your book calls standard form. But I don't really like that they call it standard form because it's not really standard form. Is f of x equals a times x minus h squared plus k, where a is not 0. So if a was equal to 0, there wouldn't be an x squared term. It would be like 0 times all of that, x minus whatever squared. Okay, so the graph of f is a parabola whose axis is the vertical line x equals h and whose vertex is the point hk. Does this make sense why this is saying we're moving to the right h, up k. So if we take a parabola and we move it to the right h and up k, that's where its starting point is. That's where its vertex is. That's what we're talking about. Okay, so it says when you complete the square, and these types of problems follow these steps. So do you guys remember the steps? We'll see. Okay, so on number 1a, so it says write the following in vertex form. So I have f of x equals 2x squared plus 8x plus 7. So what we're going to do is we're only going to look at the x terms, and we're just going to kind of think that 7 as being off to the side. We're not going to worry about it. And in order to complete the square, we need 1x squared. Okay, we have 2x squared. So we're going to factor that 2 to the front. So we're going to have a 2 and then a parentheses x squared plus 4x. And leave a little space, and we'll still have the plus 7 on the side. Okay, we are trying to find the magic number that goes right here so that this whole thing in parentheses becomes what I call a perfect square. So that when I factor it, I'm going to have something in parentheses squared. Okay, so think about when we factor things. So what we're going to do is we're going to take that number, the b value, so whatever's in front of our x, after we pulled the number out, right? So we have a 4 that's in front of the x, and we're going to do what we call have it and square it. So we're going to have it, so divide it by 2, and we get 2, and then we're going to square that number. So 2 squared is 4. And that's going to be what we add right here inside the parenthesis. So in algebra 2, you might have remembered, oh, when I complete the square, I'm also going to add a 4 to the left-hand side. So you can add things over there, but typically I leave that as f of x. So I really add a number right here, but it's not 4. Not a close, because -4 you're thinking, oh, I have to undo the operations on the same side. Okay, close, but it's not 4 that we really added. What is it?
-7.
No, that was already there. The 7 was already there. Look right here. 2 times 4. So what did we really add? 8. We added 8, right? So we have to subtract out the 8. So we're undoing how we adjusted that side. And that's okay. So some people are like, why would we add 8 and then subtract 8? Aren't we just back to the original thing? Remember, we're trying to get it in the specific form. So there's a reason that we're doing this. So now when we factor something that looks like x squared plus 4x plus 4, it factors into x plus 2 and x plus 2, right? It factors. In other words, it's x plus 2 quantity squared. Right, you guys know what I'm saying? So x squared plus 4x plus 4 factors into x plus 2 and x plus 2. That way our outer and inner combine to be that 4x. And the last terms multiply to be 4. Does that make sense? All right, so we have a 2 out front. And then we have plus 7 minus 8, so we get -1. So that is what we call our vertex form, or like I said, your book calls it standard form. So think about why this is nice. There she is. Okay, can you tell where it's been shifted? So it's like our normal x squared function, only it's been shifted in what direction? Down 1 and left 2, right? So we go left 2, down 1. So if I take this function and I go left 2 and then down 1, where's my vertex going to be? Yeah, -2, 1. Does that make sense? So that's why in this equation up there, when you have f of x equals a times x minus h squared plus k, that's why there's a minus with the x, because it's really the opposite, right? When you say left, right? Does it make sense? Yeah, did I make a mistake? Ah, dang it, down 1, -1. Thank you. So basically with the x, it's the opposite sign, and with the h, like the h, sorry, the h and the k, the h is the opposite sign, the k is the same sign. Yeah.
What about the vertical stretch?
So there will be a vertical stretch as well, but we don't really worry about that when talking about where the vertex is. So basically what would happen to this graph is you would go left 2, down 1, and then it would be skinnier than what it was originally. Okay, so we're going to roughly sketch the parabola on this graph. So let's draw its parent first. So the parent was at 0, 0, 1, 1, 2, 4, -1, 1, whoops, -1, 1, and -2, 4. So this is our normal y equals x squared. So we're moving it to the left 2, down 1. And then as Greta was saying, there's a vertical stretch by 2. So previously I had the point 1, 1. When I do a vertical stretch by 2, it goes up to 1, 2. It stretches the y value. Okay? So the easiest way to do this is to think about your original points. So if I start here and I went over 1, up 1, I'm now going to go over 1, up 2 to get to the next point. That's going to be a vertical stretch. So if you're not sure, I know a lot of you guys didn't like this on the test. You could always do a quick t-table to check a couple points if you want to. Like easy points to pick would be -2, obviously. But then maybe -3 and -1 as well. Something on the right and left of that. All right, so if I went over 1, before I went over 1, up 1, so now I'm going over 1, up 2. And previously I went over 2, up 4, so now I'm going over 2, up 8. So we're going to multiply the y's. So over 2, up 1, 2, 3, 4, 5, 6, 7, 8. So they're going to be there. So it's just a little bit skinnier. Does that make sense? All right, so next one. So let's try the same thing. So again, we need a 1x squared. So we have -1x squared. So we're going to pull out the -1. Was it Lily that caught me? Oh, it was Lucy. Dang it, you guys sat in different spots. I'll blame my glasses today. I just can't see. All right. All right, so we pull out the -1. And then we do that negative b, or not negative b over 2a. We do the halve it and square it. So divide your b value by 2 and square it. So when we divide it by 2 and square it, we get 9. So I'm going to add a +9 in there. But what did I really add to this side? Yeah. So what do I need to add over here? I need to add a +9. So when I do, I get a -1 out front. I can then factor that part that was inside parentheses. And if you did it correctly, it will be what we call a perfect square trinomial. So when we factor it, does it become something times itself? Yeah, it's x minus 3 times x minus 3. So we do x minus 3 squared. Yep, and then +1. Okay, this is now in vertex form. So our vertex was right 3, up 1. So it's 3, 1. So like I was telling you, it's the opposite of whatever was here and the same as whatever's there, because of the left-right thing. Whoops. So if we were sketching it out, we know that it's at least at 3, 1. And then really it's kind of like y = x squared, except for what? Yeah, we have to flip it over. So if you think about y = x squared and you think about those first 5 points, you have your 0, 0, you have your 1, 1, you have your 2, 4. Let's kind of keep those types of points. So we're saying, okay, now I'm going to go over 1, and instead of going up 1, I'm going to go down 1. So over 1, down 1, left 1, down 1, over 2, down 4, 1, 2, 3, 4, over 2, down 4. Does that make sense? That's the quickest way of sketching it. Okay, so this one says, can we maybe find the x-intercepts as well? How do I find x-intercepts? Yeah, 0 for y. We just talked about that last time. So if I plug in 0 for y, I get -x squared plus 6x minus 8. And we factor. So when we factor, I don't ever like to have a -x squared. So I try to pull out a negative. So I would do like -1, and then I have x squared minus 6x plus 8, because I don't like factoring with a negative out front. So now think how it factors. So we have our 2 sets of parentheses. We need our x and x. What do we need? Yep, -4 and -2, perfect. So see how those multiply to be +8, and then the outer and inner swoops combine to be -6x. So when this is all set equal to 0, we have 2 solutions. So that -1 doesn't matter. You can leave that -1 out front. But we have -1 times this parenthesis could equal 0. So that means anything that would make those parentheses equal to 0, that's what's making it 0, right? So our values that make it 0 are x = 4 and 2. Is that where we got them on our graph? Are they at 4 and 2? Yep, totally. So we did it right. Okay. This other one, that would be a little bit hard to factor. If you can't factor it, you do quadratic formula. So these ones may not have crossed perfectly on one of those grid lines. Okay, so if you're trying to find x-intercepts and you can't factor, do quadratic formula. All right, so let's try another one. So it says, write the vertex form of the equation of the parabola whose vertex is at 2, 3 and passes through the point 0, 2. Okay, so that's our HK. We were told what our vertex is. So our vertex equation looks like this. So we have a, so some number out front, and then x minus h squared plus k. So we're saying write h up k, some kind of vertical stretch or reflection. Stretch, compression, reflection. Okay, so do you guys remember in like algebra 1 when you guys were doing like y = mx plus b things? And you were like, oh, your m is 2, and you go through the point 2, -5, but you didn't have b? Do you guys know how we like temporarily plugged in for x and y to get b? So we're like, oh, y equals mx plus b. I'm going to plug in y and x temporarily to find what that b is. That's what we're doing here. So we're going to temporarily plug in these 2 points for x and y. Okay, so right now, before I do that, I have my h and my k at least. So I have minus 2 plus 3. So I have a times x minus 2 squared plus 3 equals, and f of x is just y, right? But our issue is we don't know what a is. We don't know if there's been like a vertical stretch, compression, a reflection. We just don't know. So we temporarily plug in 0 for x and 2 for y to solve for that a value. And we just solve it out. So we get 2 is equal to a times negative 2 squared, so 4a plus 3. We subtract the 3 over, we get negative 1 equals 4a. So our a value is negative 1/4. So then once we have that, we're good to go. We have all the things we need, and now we just put back in our generic x and y, right? We don't put our 0, 2 back in. So we're like, oh, we have f of x or y equals a, which was negative 1/4, x minus h is always the 2, and then k is always the 3. So that's our final answer. Does that make sense how we did that? Do we like parabolas? Yay, parabolas. You know we're going to do harder stuff this chapter than just parabolas. Do polynomials. All right, number 3. So find 2 positive numbers that add to be 110 and whose product is a maximum. So 2 positive numbers that add to be 110. So we're going to say x plus y is equal to 110. And we want the product of those numbers to be a maximum. Okay, so we're going to kind of use our calculator. Remember when we did problems where we were finding a maximum? But we could never put in like x plus y into our calculator. Okay, so what we're going to do is we're going to take this equation that says x plus y equals 110, and we're going to solve for y. So we get y equals 110 minus x. Then we go into our second equation, and we replace our y with 110 minus x. So we have x times 110 minus x equals the maximum. That's what we're going to graph. So we're graphing this for y1, x times 110 minus x. So go into your calculator. And under y equals, you're going to put x times the 110 minus x. Or you could distribute it. And I mean, some of you guys did so much like work on the test. You distributed everything in, FOILed everything out. I mean, you did a lot of work, and then like you made one little mistake. It's easiest just to leave it how it is, right? Unless it's really complicated to put into your calculator. So we're just going to leave it like that. And then we hit graph. So when you hit graph, I'm on the standard window right now. I can't see anything. It looks like there's nothing that's even been graphed. Okay, but if you think about this, this should be a downwards parabola. Do we see why it's a downwards parabola? Because you'd have 110x minus x squared, a negative x squared term. Okay, so we need to figure out where it is. So I'm trying to find 2 numbers. So x is some kind of number that adds to be 110, and they're both positive. Okay, the most this number can possibly be is 110, right? So if I go to my window and I'm thinking about my x values, I say, well, x could be 110. Probably not, but let's assume it can go up to 110. So let's make our x min 0 and our x max 110. Can you guys see that at all? It's so hard to see the green screen. Yeah. And then our y value, though, is probably pretty darn big. So if you're not sure, like, we're saying their product is a maximum. I mean, think about just like 50 and 60. kind of in the middle, right? Those had to be 110. What would their product be? 50 times 60? What's 50 times 6? 300. So 50 times 60 is 3,000. So it's going to be pretty big. So let's go up to like 5,000. Just kind of exaggerate it. So when we hit graph, now we can see that downwards parabola. Does that make sense? So this is a calculator skill. You have to get better about thinking about what your window should be. Okay, so say, okay, x is this. It's a number. I'm adding it with another number to be up to 110. So most of me is 110. Right, okay, so now we're going to find that maximum. So we're going to do second trace. And we're going to find the maximum by going on the left side and the right side. And then guess. So we're doing all this with our calculator, but there's probably ways we can do this by hand too. So it says our maximum was at 55.000002. Do you think it's probably lying to me a little bit?
Yeah, I got 55.
Yeah, calculators lie to us sometimes. So mine's not handling all those digits very well. It did a rounding error, but barely. Usually it's pretty darn close to what you want. Okay, so yeah, x is equal to 55. So if x is equal to 55, what's y equal to? It's also 55. I didn't say they were two separate positive numbers. They could be the same. And usually with maximums, that is what it is. Like if you talk about like a maximum area, like if you have like a fence, a lot of times it's just a square. All right, so question. What if I did FOIL this out? So what if I made it negative x squared plus 110x equals m, I'll call it m for maximum. And I wanted you to find the maximum of that downwards parabola by hand. You didn't have a calculator. What could you do? You could try to change it, do completing the square and stuff. Do we want to complete the square? No. Negative b over 2a, right? We could do negative b over 2a. So could use, is that what Viola said? I just couldn't hear you. All right, could use x equals negative b over 2a. And you would also get x equals 55. Okay, so you can do this multiple ways. So the same thing is true with these ones where we complete the square. Like we don't have to complete the square. We could do this in a different way. So I think I have, don't I have some problems like that? Maybe I didn't do those. Do you guys have problems where it says use the vertex? I could have swore I edited that, but oh well. So let's say I wanted to find, let's do the first one. Let's say I wanted to get this one in vertex form, but I didn't want to complete the square. Especially if I have like fractions and stuff. Can you imagine if I have fractions? So if you don't want to complete the square, just take this function and do x equals negative b over 2a. Oh, I did. It says, how could you find the vertex and write in vertex form without completing the square? I did do that. I knew I'd put that somewhere. So let's say, what was that? Y equals 2x squared plus 6x plus 7? What was it? 8x plus 7. So let's say I wanted to find the vertex form, but I didn't want to do that completing the square. Like, because some of you guys hate completing the square. I realize this. I know it's not always that easy. So what could we do? Well, we could do negative b over 2a. So we could have negative 8 over 2 times 2. So we get negative 2. We could then plug into y equals. So 2 times negative 2 squared plus 8 times negative 2 plus 7 to get the y value that goes with it. So we have 4 times 2 is 8 minus 16 plus 7. What do we get for y? Negative 1, right? Was that our vertex, negative 2 comma negative 1? Yep. So we're like, oh, well, I'm going to have a times x minus an h. So minus negative 2 becomes plus 2 squared minus, or plus k. Well, k was negative 1. So it looks like a 7 there, negative 1. So then the last thing we have to decide is, well, what's a? And it's very, very easy. When you guys use the quadratic formula, you're solving something that looks like ax squared plus bx plus c, right? Okay, look at our original problem. Ax squared plus bx plus c. That a is the same as it would be in the quadratic formula. Okay, so what's my a then? It's 2. So we replace this a with what it's equal to. It's equal to 2. And then we're done. Does that make sense? Was that easier for you than completing the square? Yeah, do you think it would be easier on things that look like y equals 3/4 x squared minus 5/6 x plus 1? Probably, right? If you have fractions, choose your battles. We don't want to do ones that are really, really hard. All right, so let's go down here. Okay, so a popular video game will be released at GameStop in a week. The store has determined that their revenue will be R of P equals negative 25P squared plus 1200P, where P is the price per game in dollars. So find the revenue earned for each price listed. So if the game is $20, I have no idea how much video games are. That's probably not even close to what video games cost, is it? Probably more like 40 or 50. $60? Oh my gosh, you guys are just blowing all your money. Okay, so if it was $20, I put that in, and I put it in my calculator, and I said, okay, they're making $14,000. That's pretty good for a video game store. All right, but if it's 25, well, let's try the same thing. So we have negative 25 times 25 squared. Well, maybe I should write my R of 25. So negative 25 times 25 squared plus 1200 times 25. So in that case, they're making a little bit more. They're making 14,375. And same thing with 30, so negative 25 times 30 squared plus 1200 times 30. This time it's a little bit less. This time they're making 13,500. Okay, so let's channel our inner Maggie Dean. Econ. Why is this true? Tell me why I can't just charge more and charge $40, $50, $60 for this game. Exactly. Look at you, Econ 101. You guys are acing it. Right? Yeah, you can't charge like $200 for something that really people would only pay $20 for. Supply and demand, right? Do we want this? We don't want this. All right, so find the price per video game that will yield the maximum revenue. So what is the maximum revenue? Explain your results. So what are we doing here? So we're trying to find the p-value that maximizes the revenue. So this is a downwards parabola. We want to find its vertex. So if I put a problem on your test and I ask for a maximum or a minimum, maybe a minimum cost for the company, right? You're going to know, oh, I should find the vertex. That's your keyword, maximum or minimum. All right, so this, I know there's no x's, so it's usually x equals negative b over 2a. What are we going to write now? We're going to write p equals negative b over 2a. I hate p's and b's for my dyslexic students. I'm sorry. I apologize. So I have negative b, so negative 1200 over 2 times negative 25. So what do we get? 24. That is the price that will maximize the revenue. Now it says, what is the maximum revenue? So how do I find the maximum revenue? Plug in 24 into my revenue function. So I have negative 25 times 24 squared plus 1200 times 24. So it's just a little bit more than that $25. It's 14,400. So if I had my calculator, which I had my calculator on that. I couldn't do all that work in my head. I mean, you could, but it'd be kind of annoying, right? We could just graph this for y1 and find the maximum. But the part that's tricky for you guys still is finding the correct window. So you might have a window and you might see part of that parabola and you'd be like, oh, I need to adjust my y min, y max, right? I need to make it go up higher. Does that make sense? So that's the skills that I was talking about in that email that we need to get better on, because I think some of you guys ran out of time on your test because you were busy like changing the window and doing all these things that maybe you shouldn't. Okay, quadratic formula. Do we remember it? Should I pull up some quadratic formula songs in a little bit? Do you all have it memorized to get low?
No, but can you play that?
Yeah, we will. All right, so use the quadratic formula to find x-intercepts of the parabola. Write your answer in exact form and also approximate. So when you see exact form, I don't want decimal answers. I want things with fractions, square roots, right? That's what I wanted to ask. Okay, but then we're also going to approximate answers to 3 decimal places. So we have 9x squared minus 6x minus 11. So we have our a is 9. You can write those if you want. A is 9. B is negative 6. C is negative 11. Some people write those down. And I always try to do a little bit of simplifying as I go. So I'm going to have x equals negative b is negative negative 6. So I'm just going to write 6 plus or minus. I always do the b squared part in my head. What is the b value when you square it?
36.
It's positive 36, right? It's always going to be a positive number there. Minus 4 times a times c. So sometimes people like to go ahead and do the a times c together. What would a times c be? Negative 99. So sometimes people will write like 4 times negative 99. Or you can just do 4 times a times c. All over 2a. So we have 6 plus or minus. And this is where I would use my calculator and I'd put 36 minus 4 times 9 times negative 11. My calculator will do that order of operations for me. So I get 432. Did you guys get 432? Over 18. Now here's the hard part. We have to simplify 432 under a root. So if you try to take the square root of 432, sadly it doesn't work out. It says 20.7846. So I know that I can probably simplify the radical. So like if I had square root of 8, I would write it as 2 root 2, right? So how do I do this with 432? So let's see what goes into it. 2 goes into it. It becomes 216, 108. So this is where, when I first taught you guys this in Algebra 2, I had you guys start breaking it down. So 2 and 216, 2 and 108. Do we know what goes into 108? 9 and 12. And then 12 is 4 and 3. Once you find perfect squares, you can kind of leave them. Or you can break it into 3 times 3, 2 times 2. But what's the square root of 9? The square root of 4, and the square root of 4. So we're going to do these together. So the square root of 2 times 2 was just a 2, right? The square root of 9 was 3, and the square root of 4 was 2. All of those are on the outside. The 3 is left on the inside. So do you guys see how it's 12 root 3? If you put the 12 back in, you would square it. 12 squared times 3 is 432. Okay. So we have 6 plus or minus 12 root 3 over 18. And now we reduce. So we have 6, 12, and 18. What do they all have in common?
6.
A 6. So this is where I drew a little cheesy heart in Algebra 2. And I said that that 18 goes both to the 6 and both to the 12. So we're reducing everything, but I would just reduce them by that 6. Okay, so if I reduce by 6, I get 1 plus or minus 2 root 3 all over 3. That is the fully simplified form. So now we want our 2 answers using decimals because that was our exact form. Now we want simplified to 3 decimal places. So take your calculator and we're going to do 1 plus 2 root 3. And then I would just hit enter. And then I would divide by 3. When I do, the first one is 1.488. Did you guys get that? And then I do 1 minus 2 root 3. and I would hit enter. That way you don't have to worry about parentheses and so on. And then I would divide by 3. So I get negative 0.821. Those are our approximated ones. Okay, does that make sense? All right, so number 6, solve the equation. So we're going to go ahead and multiply it all out. So we have 3. We're going to do x minus 1 times x minus 1 minus 4x minus 8. I'll go and distribute there. Equals x squared minus 5x. So we go ahead and we FOIL the x minus 1 times x minus 1. So we get 3 times x squared minus 2x plus 1 minus 4x minus 8 equals x squared minus 5x. We continue simplifying. This is a good place to be an active note taker, right? You could just go ahead and do it on your own and then look up to see if you got it. So we got 3x squared minus 6x plus 3 minus 4x minus 8 equals x squared minus 5x. So what you should notice is that we have x squared terms and we have x terms. So when we have x squareds and x's, we need to factor. We need to get everything on one side and set it equal to 0. So I'm going to subtract the x squared over and I get 2x squared. Then I have negative 6x minus 4x was negative 10x. But I'm going to add the 5x over. Can you guys do all that in your head? So if I had negative 10x and I had negative 5x on the other side, I'm going to add this 5x over. So I get negative 5x. And then the same with just the numbers without x's. We have 3 minus 8 is negative 5, and then we don't have anything on the other side, so we just have minus 5 equals 0. And then we hope it factors. I don't know, does it? 2x and x. It doesn't factor, yeah. You can try, but 5 and 1 would make that 10 and 1. So 10x and 1x don't combine to be negative 5x. So when it doesn't factor, quadratic formula. This is where all my calculus students groan. And I'm like, really? In all of calculus, quadratic formula is what we're groaning about? Like, this should be the easy stuff. All right, so we get x equals negative b, so 5, plus or minus the square root of b squared, so 25, minus 4 times a times c, all over 2a. So we get 5 plus or minus. It's going to be 25 plus 40. 25 plus 40 is 65. Does that reduce at all? No, it doesn't, because 65 is 5 and 13, so neither one has a perfect square of them. So if I round my answers to 3 decimal places, I get my calculator. I would do the 5 plus the square root of 65 first, and then divide by 4. And I do my 5 minus the square root of 65 divided by 4. So we get 2 answers. So the first answer is 3.266, and the second answer is negative 0.766. Those are our 2 answers. Good? All right, this is the last one for this section. All right, so the parabola intersects the line y equals negative x minus 1. Find the intersection points and verify with a graphing calculator. Okay, so we have a downwards parabola intersecting a line. At most, there can be 2 answers, right? There could be 1 answer if it just barely touched it, right? So let's see. So previously, when I was finding like where a line intersected another line, I would do substitution or elimination. This is kind of the same thing. It's like we have a system of equations. But we can't really do that elimination thing very easily because we have x squareds and x's. So we can't like line them up.
Make them equal.
Yeah, so see how we have y equals and y equals? We can take this negative x minus 1 and we can just kind of plug it in right there, right? And replace the y with it. So we're going to say negative x minus 1 equals negative x squared minus 3x plus 4. So we want to get everything on one side. So I'm going to add the x squared to the left side because I like my x squareds to be positive. So I add the x squared over, I add the 3x, so I get plus 2x, and I subtract the 4, so I get minus 5 equals 0. Did I do something wrong? It doesn't factor, does it? I think I'm good. I think I wanted it to factor. Thought it was going to be a nice number, but that's fine. All right, so if I'm going to find this, I'm going to do my quadratic formula. So negative b plus or minus the square root of b squared is 4 minus 4ac all over 2a. So we get negative 2 plus or minus the square root of 24. How do I simplify square root of 24? 4 goes into it. Yeah, 4 and 2, so 2 root 6 over 2. I'll do my little Hardy thing here. So I get negative 1 plus or minus root 6. Okay, so that's the x values of the intersection points. So I could find those as decimals if I want to. So it would be 1.449 and negative 3.449. Okay, those are the x values of the intersection points. So those are like here. Like that. How do I find the y value that goes with them? Yeah, plug it in. And which one's easiest to plug in for? Yeah, definitely this one, right? So if I take my negative 3.449 and I multiply by negative 1 and then subtract 1, I get 2.449 for its y value. And if I take my 1.449 and I multiply by negative 1 and then I subtract 1, I get negative 2.449. Oops. There's more room. So I'll let you guys go on break and then I'll show you on the calculator how talk about how to do this on the calculator. So if you go to your calculator and under your y equals, you put in negative x squared. So make sure when you put in negative x squared, you put the negative sign, not the minus sign at the beginning. And then minus 3x plus 4. And then put the second, like y2, as negative x. So again, negative, and then the x, and then minus 1. If you put minus x minus 1, it will say error. So you'll know that you guys did that wrong. All right, so then we hit graph. Now mine is still set on that last window that we had, which was really, really high. So now it's saying that I can't see anything again. So when that happens and you want to go back to your negative 10 to 10 window, you just hit zoom and then go to zoom 6. So number 6 is the standard negative 10 to 10 window, and I would start with that. So yeah, now we can see the parabola and we can see the line going through it. So what we're trying to find are the intersection points. So intersection points we do by doing second, trace, intersect. And you basically just get right on top of where you think it's intersecting. And you don't have to do like a right bound, left bound or anything. Just hit enter for first curve, second curve, and then guess. So it says negative 3.449, comma, 2.449. Is that one of the ones we had? Yeah. Yep. Isn't that much faster? Yeah. So again, if you have your calculator, use your calculator. And that's one thing that people have to learn when they go on to AP Calc, because there is a calculator portion to the exam and there's a non-calculator portion. People spend a lot of time, because they're good math students, they want to do everything by hand, but sometimes you shouldn't. Sometimes you should use the faster method. So we have 1.449 and negative 2.449. Well, that's this other one. Does it make sense? So we got all the answers. Perfect. All right.